So we need to get it's time now to get your part out of OnShape and into Cura. Cura is what we're going to use to take and 3D print our parts. So the first thing we need to do is most people are going to come up to the menu up here and say, all right, what do I need to do? I need to print. Great. Well, unfortunately, that's going to get you a picture. We don't want a picture. We want to be able to create a 3D model of our part. So what we need to do is come down here where it says Part Studio 1. We're going to right-click, and we're going to rename this file. And it's going to contain an identifier for you, what class you're in, and what this part is. And you're going to get a second chance to rename this part. Just know that if your part comes to the printer and it still says Part Studio 1, I'm taking it out of the printer, I'm deleting the file off the thumb drive, and it is not getting printed. Too many people will try and put that same file name on there. It will get confusing, it will get messy, and I don't want to deal with it. So, simple fact is you must rename your file in order to print it in this classroom. Period. End. All right, so now that I've got my tab renamed down here, I can go ahead and I can get this part ready to go to print. I'm going to come either to where it says Part 1, I can right-click, and I can choose to export here. If I only needed to get one part, say out of an assembly of 15 parts, I only needed to reprint one of them. I can choose one part to reprint. I can also come down here on the tabs, and I can right-click there, and I can choose Export there as well. Either one of them will get you to the same situation. This tab on the bottom will set it to print everything you see on that screen, whereas if I chose an individual part, that's all that will be printed. This does give me the option here to export unique parts as individual files. So if I've made an assembly with multiple parts that I want to be able to assemble separately after it has been printed, not what is known as a print in place, but a separate print, I would check that off, and every part listed in my part tree over here would come out as its own individual STL. Here you can see is the second chance we have to rename our part. It will pull in what it says in your tab. In this case, it pulled all my information, which is great. So we're looking at this file format is STL. That is kind of like the PDF of 3D printing. That will get you into any slicer and get you ready to go. The rest of these that you see in here, with the exception of this 3MF, are predominantly used by other 3D modeling software, and that'll allow you to move your parts in between different pieces of software. 3MF is tied in with a separate 3D printer that we don't use. You're going to keep this as binary, and the units is the part that throws most students off. Your units, I know you built in inches. It's okay. This says millimeters because while you have grown and you speak English, you speak English standard sizing, you use inches. Here, our printers speak millimeters. So we need to make sure that everything is exported in a language that our printers can speak. In this case, it happens to be millimeters. If you turn your part and leave that as inch, what you're going to find is when you export this and it goes into the printer, it's going to pop up with a warning that says part scaled by 10,000%. The printer's going to go, ooh, you're trying to print something that's 2 millimeters by 2 millimeters by half a millimeter? Well, that's exceptionally small and not likely to be what you actually wanted. So it scales everything up so you can see the part and be able to modify and get it to the size that you need. For our purposes, just make sure this stays in millimeter. Resolution is fine, and I like to leave this download and store file in a new tab. What that will do is once the file is generated, it will simply add an additional tab down here in your Part Studio. You can see one down here from 6th period when I worked on this before. And what that does is it allows me, anytime I reopen this file, I can access that and download it again without having to go through this process. I just find it nice that it's all conveniently in one spot. Okay, and in a second, there it is, and it's also popped up on here. The next piece you're going to do is you're going to go to Cura. Cura is what we call our slicing software. If you type in C-U-R-A in that spotlight, you're going to see one that says Ultimaker Cura.app. Your symbol will be a little bit different. I'm using an older version on this computer. Yours will have a darker blue background, but still have this letter C and our polygon shape behind it. So once I open that up, that's going to be down here. Where's my Cura? There's my Cura. So I'm running version 4.8. Right now in self-service is going to be 5.1. But if you don't know how to do that, simply go to that search bar, type in self, it'll pull up the lovely red icon for the self-service, and you'll be ready to go. If you run into that situation, let me know. I'll want to make sure that you're set up properly for the Ultimaker S5 that we are using in this class. We'll just take another moment to load this up. Ooh, stay away, spinning beach ball. There we go. Okay, now we're going to want to go ahead and get our STL file into Cura here. So we've got two different ways we can go about doing that. I love sliding over, and right here's my window. I've got the download tab popped up here, and I will take and hold down. So my mouse is held down, and I can let go, and the part's going to show up in here in a second. The other option is I can come up here to my file icon, and this is one of the other reasons why it's really important that we look at our file naming so it's easy to find once we go to bring it into Cura. And there's my part right there. And I'm going to say open up. And there it is. We call this being on the stage. This is where it's being prepared and ready to go. Up top is where you're going to need to worry about how to set up for this print. Make sure in this part here, you'll have the 1 and the 2. These are for the 2 different materials that we can have loaded into the printers at any given time. Make sure that you are using the correct plastic. Right now, I am finishing off the last bits of PLA that we have. That will be replaced by ABS. Right now, we have 1 printer that is set with ABS. The other 2 are set with PLA. So we need to make sure that you know what type of plastic is being used because they each respond to different amounts of heat and have different ideal situations to work in. So we got to make sure we got the right stuff there. In this case, I know I'm going to the printer that has ABS loaded, so I'm good to go there. Next up is figuring out how thick I want each layer to be as the printer prints it out. At 0.15 millimeters is perfectly fine when you know what you're up against. You may wind up going and using a 0.2 millimeter. That's fine as well. But the other piece I want you to think about is what we say is infill. So you see this little check box lines going through here. This is saying 20%, which means that this block of plastic down here, instead of being one solid piece of plastic, is instead going to be 80% air, 20% plastic, but laid out in such a way that it supports everything as needed. Last piece that really, really matters is this build plate adhesion, and we need to make sure we put what's called a brim on our parts, especially for these parts because they're flat and long. All this is going to do is add a little piece of plastic, one layer of plastic on your first layer of print that's just going to extend out how wide your base is. What that does is it makes it easier for your part to hold on to the bed and stay adhered instead of peeling up as it cools off. It has a tendency to want to pull away from the bed. So we make sure that build plate adhesion is turned on. Then I'm going to say slice it. All right, cut it up. Run that knife through every 0.15 millimeters. And if I look in my preview section, there's my layers. So I've got 62 layers for this print. And as I go down to the different layers, if you watch down here on the part, you'll see, there we go. So there is around layer 31. You can see that instead of being a solid block of plastic, we've got individual lines running through here. So this is going to support everything that we need, but cut the weight down, cut the costs down, and make it overall a better project for us. So you can see each layer. And if you really want to go in and see how the printer is going to print each layer, that's what this little guy down here is. It's showing us every single bit of plastic as it gets laid down by the printer. It's showing us where it's going to be and how it fits out. I do not pretend to understand the algorithm that they use to choose what piece of plastic to print when, but that's the way it works through it. I'm going to go ahead and I'm going to say save to file. When you put your thumb drive in, make sure, one, you're going to need to make sure you have one of these USB-A to USB-C adapters so that you can connect your thumb drive to your laptop. Then you're going to get a pop-up that says save to remote device. So you'll be able to click on that and choose your thumb drive. And when you save the file, that's going to be ready to take it over to the printer. Make sure that it's got the name that makes sense. It's going to stick this S5, that means Ultimaker S5, that's the printer it's set to go to, and then the rest of your information. And you would have over here the, under the locations, the thumb drive will show up over there. Once you click save, take the part over to the printer, and you're ready to go from there. Anything goes wrong, anything looks goofy, anything doesn't line up right, come, let me know. That's why I'm here. Let me know if you need anything else. Otherwise, happy printing.